So now we go for the next chapter in maths, that is indices. So indices, we had done a part of it in the 8th standard also. So we know indices is nothing but expansion, the exponents. That is, if I say that it is a raised to m, that means I am multiplying a, the number a is being multiplied m times. So this is just the meaning of a raised to m. So a raised to m is a into a into a into a into a m number of times. Now over here, this is called as the base, and this over here is called as the index or exponent or raised to the power of. So when I write over here something like 2 raised to 4, I can write 2 exponent 4, 2 raised to the power of 4, 2 with an index 4. But what is the meaning of this? It is just that 2 into 2 into 2 into 2 gave me the answer as 2 to the 4, 4 to the 8, it was 16. So 2 raised to 4 is equals to 16, right? Now, for doing any particular sums of indices, you need to know the rules of indices, the laws, the rules of indices. Now, there are around 9 to 10 different formulas which you are going to see one by one, which has to be very well by hearted by you so that you can solve each and every sum properly. So, we'll go one by one with the different formulas what we are having over here, or the rules or the laws, whatever we want to call it as. So the laws are this way. The first one is a raised to m into a raised to n is equals to a raised to m plus n. Now remember one more thing is that this is true on the reverse order also. So if I am given a raised to m plus n, it also means that it is a raised to m into a raised to n. Right? So that's why we not only need to learn this way but also this way. Both ways you need to learn it so that the application wise you know what is to be used where. The next one is a raised to m whole raised to n, which is nothing but a raised to m n, that is m into n. That is the second one. The third one will be a raised to m divided by a raised to n. This will give me a raised to m minus n. Got it? Now, it may happen in this case that your n is greater, then you get a negative sign. So there will be a separate rule for how to convert the negative sign into positive. So right now we'll just consider it this way. The next one is fourth one, a raised to m into b raised to n m. If both the things are same, it is same as ab whole raised to m. Okay, if the index of both the numbers when they are multiplied are same, I can take the whole thing in a bracket and then I can club the index together. Same thing can also happen in case of division, that if it is a upon b whole raised to m, which is nothing but a raised to m upon b raised to m. Clear? Now, the sixth one is, as I told you over here, if I would have got the answer as a raised to minus something. So if it is a raised to minus n, it is nothing but 1 upon a raised to n. Okay? A raised to minus n is equals to 1 upon a raised to n, which can also be written as 1 upon a the whole raised to n. The same thing. It's one and the same thing whether I write it this way or this way. Normally you write it this way. The next one over here is if a raised to 0 is always 1. So anything raised to 0 is 1. Anything raised to 0 is 1. Eighth one over here is that if I have got the nth root of a, okay, nth root of a is nothing but a raised to 1 upon n. Okay, this is, for example, if I say cube root of 2, so it is nothing but 2 raised to 1 upon 3. Or when I say just root 3, it is nothing but 3 raised to 1 upon 2, because this is nothing but square. It's square root. That's why you don't put for a square root the 2 over here. So here you need to say 3 raised to 1 upon 2. This is an example for this thing, that how this is used. The ninth one over here is, if I have got over here that a raised to m is equals to b raised to m. Okay, if this is the condition given to me, then it will be seen that this is possible only when therefore a is equals to b if m is not equal to 0. Because if it is 0, it is 1. See, this is to 0 is 1, this is to 0 is 1. In that case, a is not equal to b directly. But here, if I say that a, m and n are not equal to 0, then I will see that a is equals to b if these two are same. These two are same, and it will be like this. Okay. And same way, if it is like this, that a raised to m is equals to b raised to n, a raised to n, then m is equals to n. Okay. So this is, of course, if provided a is not 1, that provided if a is not equal to 1, because 1 raised to anything will be just 1. That's why it is this way. Got it? So these are the formulas which you need to learn by heart. A raised to m into a raised to n is a raised to m plus n. A raised to m whole raised to n is equals to a raised to m into n. A raised to m upon a raised to n is equals to a raised to m minus n. A raised to m into b raised to m is equals to ab raised to m. A upon b the whole raised to m is equals to a raised to m upon b raised to m. A raised to minus n is equals to 1 upon a raised to n. A raised to 0 is 1. Nth root of a is equals to a raised to 1 upon n. And this is, okay. Got it? So these were the formula for the indices or exponents. Right? We'll now go for the exercise directly. So exercise is exercise number 7 from the textbook. Exercise number 7. Okay. This formula, it is better that you copy down in your notebooks properly at the start of this particular chapter, so that you can just copy down in the start of the chapter, so that you are aware about the different formulas, and you know that the importance of this particular formulas. So now they are given us there are good many number of questions in the exercise 7. We will start with the first ka first, and second ka first, and third ka first. So we'll directly do the first sums of all the sums, and automatically the second of each and every will be your homework. So I'll do this way, that fine, doesn't matter, I can anyway ask me the doubts for the other sum. So first one, it is 81 upon 16 the whole raised to minus 3 upon 4. It is 81 upon 16 whole raised to minus 3 upon 4. You can see over here, what we need to do is, in any case of indices, the main thing is that we need to get rid of the denominators in this particular fractions of the exponent. See, the exponents may denominators over here are always irritating. So it's better that we get rid of them, because otherwise we will require the LCM and things like that. So basic thing is that we try to make this, we try to cancel this. How do we cancel this? You see that 81 and 16 both are numbers which are such that they are going to be this way, that it is 81 is nothing but 3 raised to 4. 3 3s are 4, 4 2s are 4, 3 3s are 9, 9 3s are 27, 27 3s is 81. So automatically it is 3 raised to 4 is 81, and 16 is 2 raised to 4. So accordingly, we will have over here 3 upon 2 the whole raised to 4 into minus 3 upon 4. So the 4 gets cancelled. So finally we get 3 raised to 2, the whole raised to minus 3. Now because it's minus, I need to make it plus, so we'll use the formula. So the formula what we'll be using will be a raised to minus n is equals to 1 upon a raised to n. So you reciprocal this, accordingly it will be 2 upon 3, the whole raised to 3. So the answer will be 2 to the 4, 4 to the 8, and 3 to the 9, 9 to the 27. So answer is 8 upon 27. Understood? The formula which I used over here was a raised to m upon a raised to m, b raised to m is equals to a upon b whole raised to m. This is what I used here. This became this. And then I used this formula to get this. Okay, this is the formula I used. Got it? Yeah, writing this over here is not compulsory. Good if you write it, better, but not compulsory for them. I don't think there should be any kind of a marks being cut for not writing these formulas, because the application is more important over here. So that was the first sum. Now we move to the second sum. It is 2a raised to minus 3 b raised to 2 whole raised to 3. So here what we'll do is we'll take this, multiply this inside. So we are going to use the formula a raised to m, the whole raised to n is equals to a raised to mn. So here it will be 2 raised to 3 into a raised to minus 3 into 3 and b raised to 2 into 3. That will be the resultant of this 3 going inside. So this 2 raised to 3 is 8, 2 to the 4, 4 to the 8. This is a raised to minus 9 and this is b raised to 6. Now this a raised to minus 9 is there. I will use this formula to make it in the denominator. So accordingly it will become 8 b raised to 6 upon a raised to 9. This is the final answer. Easy? Move on to the next question. Question number 3. Is x raised to minus 1, y raised to minus 1 upon x raised to minus 1 plus y raised to minus 1. Okay. We can write this as 1 upon x into 1 upon y upon 1 upon x plus 1 upon y, because I know that a raised to minus n is equals to 1 upon a raised to n. So here n is just 1, so it is just 1, and it becomes just x and y. The upper one becomes 1 upon xy. The denominator will become, now take the LCM, so y plus x upon xy. You can see the xy gets cancelled, so we get the answer is 1 upon x plus y. That's the final answer. Okay, got it? I'll also cross check the answers from behind so that there is no issue later on. So that's exercise number 7. And we did the 3 sums. As first was 8.27, second one was 8 a raised to minus 9 b raised to 6, yeah, and third one was 1 upon x plus y, yeah. So all 3 is what were correct. Next one. Question number 4. It is 3a upon b minus 1 plus 2b upon a minus 1. Again minus 1, so it is nothing but 3a upon 1 upon b plus 2b upon 1 upon a. Denominator becomes numerator, so this just goes upwards. So this will be 3ab plus 2ab. Answer is 5ab. A really quite an easy sum. That was sum number 4 of exercise 7. Now we come to sum number 5. Okay, exercise 7. Sum number 5. 8 upon 125 whole raised to minus 1 upon 3. Very easy sum. This is nothing but 2 raised to 3 upon 5 raised to 3 whole raised to minus 1 upon 3. That is 2 upon 5 whole raised to 3 into minus 1 upon 3. 3 cancels. So 2 upon 5 whole raised to minus 1. Answer is 5 upon 2 to get rid of this negative sign, taking the reciprocal. Sum number 5. Now we move on to sum number 6. Again, quite an easy sum. It's minus 1 upon 27, the whole raised to minus 2 upon 3. That will give me as minus 1 upon 3 raised to 3. This is also 1 raised to 3 minus 2 upon 3. That gives me 1 upon 3 minus, this will be 3 into minus 2 upon 3. 3 cancels. So now it is minus 1 upon 3, the whole raised to minus 2. Accordingly, it will be minus 3, the whole raised to 2. Now I know the square of negative number is a positive number. So minus 3 into minus 3 is 9. So the answer for the sixth sum is 9. We'll check out the answer. Question number, exercise number 7. Question number 5 was, it is 5 upon 2, that is 2 1 upon 2. Yeah, you can write it in the mixed form. And next one is 9. Yeah, so that was fifth sum and the sixth sum. We move on to sum number 7. Sum number 7. It is 27 2n upon 3 into 8 raised to minus n upon 6 upon, this is in brackets, 18 into minus n upon 2. Okay. Trying to get rid of the denominator as far as possible, you get it over here as equals to 3 raised to 3 into 2n upon 3 into 2 raised to 3 into minus n upon 6 upon, this is nothing but, now 18 is nothing but 2 into 2 into 3, it is, 2 into 3 into 3. So 18 is 2 into 3 into 3 raised to minus n upon 2. So that gives me over here, this gets cancelled to 2. So you get over here 3 raised to 2n into 2 raised to minus n upon 2 whole upon 2 raised to minus n upon 2 into 3 raised to minus n upon 2 into 3 raised to minus n upon 2. Or else, we'll make it slightly simpler over here. We'll make this as a 3 into 2 square. So accordingly, what I'll be getting over here will be 3 into 2 into minus n upon 2. So the 2 gets cancelled. So what I get is 3 raised to 2n into 2 raised to minus n upon 2 upon 2 raised to minus n upon 2 into 3 raised to minus n. So this and this are same. So this gets cancelled. Okay, or else we'll do one thing, instead of cancelling, we'll use the exponent method only to cancel it. So it will be this way. We'll take it as now 3 wala will be 3 2 raised to n minus of minus n and 2 raised to minus n upon 2 minus of minus n upon 2. So this will be 3 raised to 3n and this will be 2 raised to minus n upon 2 plus n upon 2, which is nothing but 0. So it is 3 raised to 3n into 2 raised to 0, which is 1. So it is 3 raised to 3n as the final answer. I am trying to put more and more steps here so that you understand it properly. Otherwise, you could have easily skipped certain steps and got the answer directly as 3 raised to 3n upon 2, because here writing this thing may not be required. You can easily cancel this thing also. So, but just to make you understand properly, I given all the steps which were possible over here. So accordingly, we get the answer as 3 raised to 3n. We can check up the answer. It is exercise 7. This was the 7th sum. So 3 raised to 3n. Yeah. We come to the next question, that is question number 8. Question number 8 is given as 8 minus 4 upon 3 divided by 2 raised to minus 2 raised to 1 upon 2. Okay, that's the question. So this is nothing but 2 raised to 3 into minus 4 upon 3 upon 2 raised to minus 2, because divided is nothing but upon, and the whole thing raised to 1 upon 2. So this 3 gets cancelled. Now I got over here 2 raised to minus 4, and this division, so it is minus of minus 2 and whole raised to 1 upon 2. So that gives me 2 raised to minus 4 plus 2 is minus 2 into 1 upon 2. So 2 gets cancelled, is 2 raised to minus 1. So answer is 1 upon 2. That's the answer. That is 1 upon 2 as the final answer. That was sum number 8, 1 upon 2. We move on to the next one, sum number 9. Sum number 9 is 3x square raised to minus 3 into x raised to 9 the whole raised to 2 upon 3. Okay, this was the question. So this is nothing but 3 raised to minus 3 into x raised to 2 into minus 3 into x raised to 9 into 2 upon 3. So it is 3 raised to minus 3, x raised to minus 6 into x raised to 6. So it is 1 upon 3 raised to 3 into x raised to minus 6 plus 6, because it's multiplication. So addition over here, which is 0. So it equals to 1 upon 27 x raised to 0, that is nothing but 1 upon 27. That's the final answer. We'll check it out, the answer. Question number 9. Question 9, 1 upon 27. We move on to the next sum, question number 10. Question number 10 is 3 square raised to 0 plus 3 raised to minus 4 into 3 raised to 6 plus 1 upon 3 the whole raised to minus 2. Now this becomes 3 raised to 0 plus 3 raised to minus 4 plus 6, because it is multiplication, plus minus को remove करेंगे तो it will be 3 raised to 2. I know that 3 raised to 0 is 1 plus this is 3 raised to 2 plus 3 raised to 2. This is nothing but 1 plus 9 plus 9. Is it? One sec. Let me cross check. Yeah. Plus ही है और इधर में plus ही. Yeah. So the answer is 19. Let's just check up the answer. The answer for the 10th sum is 19. Yes. Okay. So that was the 10th sum. Okay, next sum we'll do it in the next video.